And remember, if you need a calculator, you can grab one. Yes, yes. Yes, 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 yes. Okay, yes, yes. You still going? Yes, yes. 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 Yes, yes. 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 Yes, 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 yes. Yes, 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 yes. Like I said, sit back and enjoy the easiness because it doesn't stay easy for long. What are you doing? Okay, in your calculator, type in the calculator. And do math. Can you do that one again? Type in, you did that. It should be 4. Yep. Yeah. 4 divided by 5 in your calculator. Uh-huh. Took that with me. Good job. Looks good. So far. Looks good. You're fine. You're fine. You're fine. Looks good. Looks good. All right, let's look at them real quick. And again, I never assume that anybody already knows something. So in my calculator for the first one, I'm going to do 4 divided by 5, top divided by bottom. So that gives me the 0.8. 0.8, that's my decimal answer. So my decimal is going to be 0.8. To turn a decimal into a percent, you pick up your decimal and you whoop whoop. That right there reminds me to whoop whoop. And the whoop whoop is located on the right hand side, so we whoop whoop to the right. So it's going to be 80%. You don't have to put the decimal at the end, I just put it to let you know that where it whoop whoop to. Now, I'm going to go ahead and do this one. Decimal 2% is a whoop whoop to the right. So it was 0.35, I whoop whooped, so it's going to be 35%. Okay, now for this one we're going backwards. So this one was a percentage and we're now going to the decimal. Notice for this one, the whoop whoop is now on the left. So we are going to take the 24 and we are going to whoop whoop backwards. So it's going to be 0.24. There's that one, and there's that one. The easiest way to turn a decimal into a fraction, if you've never heard of math inner, you have been leading a lonely life. It is 0.35, which is your decimal, and you do math inner. 0.24, math inner. And you are allowed to use these same calculators on every test. We just give them to you, but you will have a calculator on every test that you take. So I did math, enter, and it gave me my fraction. We good? All right, now, True or false? The shape of the distribution shown is classified as skewed left. Raise your hand if you think it's false. Raise your hand if you think it's true. Raise your hand if you don't know. Raise your hand if you don't care. It is false. What is this one?
Right.
Good. Your outlier is here, so it is skewed right. True or false? This is uniform.
False.
False. What is it?
Bell.
Bell shape, normal shape, symmetric, however they want to list it. Rolling the dice, an experiment was conducted in which two fair dice, I have a lot of people who don't know what fair dice are. Fair dice just means they're legal. Y'all, in this world, people do illegal things. Who would have thought? Sometimes they put lead in dice so that they land on one side more than another. So fair dice just means that they're legal. Now, you're also going to see in this math class the word die, D-I-E. Die just means one dice. Mouse and mice, dice and die. So dice is two of them, die is one of them. So fair dice means that it's two legal dice. They were thrown 100 times. The sum of the pips, the sum of the little numbers, the pips are the little dots, showing up on the dice was recorded. The frequency histogram is given below. So that means I take two dice, I throw it down, and I count. There's a 1 there and a 3 there. I add them up. The sum is 4. So I put a tally mark. So that means 5 times the sum was 3. So that means a 2 and a 1 or a 1 and a 2 showed up 5 times. Y'all with me? All right, so now we have to answer some questions. Determine the percentage of a time that 7 was observed. Okay, how many times was 7 observed? 15. Is that the percentage? That is the,
Yes.
15 represents the frequency. So that means that 15 times a 7 was observed. They want a percentage. So what do we have to do with that 15? Divide it by the sum of everything. Well, y'all, we got lucky. Right here, they're telling you that the sum of all of those things, if I add all of those things up, it's telling me it's going to be 100. So we got lucky. So we're going to divide that by 100, which gives us 0.15. And then what do we have to do?
15%.
Whoop whoop, because they wanted a percentage. So y'all would have gotten lucky on this particular problem had you said 15% because it was 15 out of 100. But had it been 250 or 300 or something, you wouldn't have gotten as lucky. Describe the shape of the distribution. Describe the shape of the distribution.
I would say right, but then, I mean left, but then I would say
So this is the shape of the distribution.
yeah.
It's a little skewed left.
When I saw this problem, I am totally with these two. I saw it as a little skewed left.
But it starts at 0, which it shouldn't. It should start at 2.
Okay? So, it's not a whole lot skewed left, it's just a little bit cattywampus. The book says it's normal.
If it started at 2, it'd look fine. But since it starts at 0, it looks weird.
See, I don't think that that is truly like symmetrical, bell-shaped symmetrical. Symmetrical to me is like a butterfly or like a heart, where the left side and the right side look alike. This one's only this big. This one is this big. So So to me, it doesn't look normal. To me, it looks like it's a little bit off-center. So I personally think that it is left skewed. The book said that it's bell-shaped. I personally would not give you question F on a test. Now, on homework, it's fair game, because y'all can do it over and over and over again. I don't feel sorry for you. But on a test, I personally would not give you this particular question. It's either going to be a definite bell shape or it's going to be a definite skew. All right, number 11, how many students were sampled? How do we figure that out?
Add on.
Add all those numbers up. So we would do 2 plus 3 plus 13 plus 42 plus 58 plus 40 plus 31 plus 8 plus 2 plus 1, and that's going to give me 200. Yay?
Yeah.
Determine the class width. What do we say?
10.
Because what if I told you first, what are the classes? What's the first class?
0 is 59. Or would it be 60 to 69?
60 to 69. What's the next class?
70.
70 to 79, 80 to 89, 90 to 99, 100 to 109. Y'all with me? 110 to 119, 120 to 129. Those are my classes. So to get the class width, I'm going to subtract 2 consecutive lower class limits. So it's going to be 70 minus 60, which is going to give me 10. Because this is the beginning of this class, this is the beginning of this class, so I subtract those 2. Okay, so we're already doing C. So this is going to be C. Identify the classes and their frequency. So what is the frequency for 60 to 69? What's the frequency for 70 to 79? 13, 42, blah, blah, blah. And it goes from 150 to 159, and what is that frequency?
0.
150 to 159 is going to be 1.
Okay.
Y'all with me?
Oh, I see it.
42, 58, 40, 31, etc. Which class has the highest frequency?
100.
The highest frequency is the one with the biggest bar, the one that the most people said. So they don't want to know how many people said it, they want to know which class. So they don't want to know 58, somebody's at my side door. They don't want to know 58, they want to know what class it is. So it's going to be 100 to 100, let me do it in a different color. Let's do right there. So it's going to be 100 to 109. Who had the lowest frequency?
150 to 159.
150 to 159. So my lowest frequency is going to be my lowest bar, which is 150 to 159. And if you're not seeing where I'm getting this from, you need to stop me. What percent, what is that screaming? What percent of students have an IQ of at least 130? So I want to know how many students are 130 or smarter. How am I going to do that?
And 130. 8, 2, and 1.
We're going to take 130 and smarter, which means we're looking at 8, 2, and 1. So I'm going to take this, and this, which is the 130 and smarter. So 8 plus 2 plus 1 is 11. Am I done? Because they want percentage, what do I need to do next?
Divide by 200.
divide it by the total, and what is my total?
200.
200, which means, y'all, if you screw up on part A, you're automatically gonna screw up on part F. So in my calculator, I'm gonna do 1100 divided by 200. Am I done?
Nope.
No.
No. I now have to turn that into a percentage. So what is my percentage for F gonna be?
5.5.
So 5.5% of the students that I surveyed in my sample of 200 have an IQ of 130 or higher. Did any students have an IQ of 165?
No.
160 is where it stops. This would be 165. Nobody had an IQ, there's not a bar there, so it's a height of 0. What kind of distribution is this? They didn't ask you.
Yeah.
This one's a pretty bell. That one looks very symmetrical. All right, let me let you try one. This one only has 4 parts. This is frequency histogram, number of alcohol-related traffic fatalities. Make it a little bit bigger. Determine the class width, identify the classes, which class has the highest frequency, and give me the shape of the distribution. Alright, so Mr. Jackson, you go by Joshua?
Joshua or Josh?
Which one do you want, Boo?
Either one. Josh.
Josh? Alright, so Myers is the only one that we're missing. Travis, you need to get that MML orientation done by Friday.
Right. Oh, this one.
Yeah. And same thing for you, Josh, get that MML orientation done by Friday. You did the syllabus, y'all both did the syllabus one, you just hadn't done that second one. Courtney, what is my class width?
200.
Very good. What she did is she took any two beginning of the classes. So I could even have done 200 minus 400, or 1,000 minus 800, or 200 minus 0. So 400 minus 200 gives me a class width of 200. All right, let's pick on Austin. For the classes, tell me the first class.
0 to 199.
0 to 199. Then 200 to
Or 399.
399. Because you got to back that thing up. Because whenever you get to this one, you gotta back that thing up. You get to this one, back that thing up. Okay? So 400 to, anybody? 599. And then we are gonna keep going, 600 to 799, 800 to 999, 1,000 to 1199, 1,200 to 1399. Those are gonna be my classes. Equation, what is my highest frequency? Which class has my highest frequency? 0 to 199. Describe the shape of the distribution. Travis,
Right skew?
you all over that skewness, aren't you?
Yes, ma'am.
Right skew. Questions? We are all done with this section. I go to save. Now, let's look, I'll save it in just a second. Let's look at what's on our test from this section. Use a graph to calculate a percentage. We just did that when we said like what percent had a 130 or above. We added them up, divided by the total, and woot. That's what I mean by that one. Apply the definition of class width. 400 minus 200, we just did that. Class limits. Lower class limit was the smallest one. Upper class limit was the biggest one. Distinguish between a bar graph and a histogram. Bars don't touch or bars do touch. Okay, so that's what we need to know in 2.2. Now we're moving on to 3.1. 3.1, again, still talks about the shape of a distribution. It's all kind of leading in together. So, let's talk for a few minutes about that before we take our break. There's 3 types of, you want to take a break and then talk about it, or do you want to start talking about it and then take a break? Take a break. Go ahead and take a break. 10 minutes. I'll see you back in 10 minutes. It's 12:15. Y'all gonna be fired. Thank you.